There are questions that came up about net force. So I want to address that today and with a live audience here. And so we're going to start with taking a look at this car right here, or actually we call it a sled because there are no wheels and it applies a little bit more friction across the table. So as we take a look at this car sitting on the table and we ask this physics question of, is this car in motion? Your most obvious answer would be, as you're looking at this car, is this car in motion right now?
No.
That is correct. It is not in motion, but it really is in motion. Let's clarify that truth right now, because this car is in motion. Think broadly. How is this car in motion?
Because the Earth is moving.
That's right. The Earth is moving. And so this car is moving at about 1,900 miles an hour as the Earth is rotating. But it's moving in another way. As the Earth is spinning around the sun, it's going about 67,000 miles an hour. So this car really is in motion. However, for all intents and purposes, because we live on Earth and things don't appear to always be moving, we have a car that's sitting still on the table. We call this car at rest. Newton discovered a law. What law is this abiding by? That is right. That's Newton's what law?
First.
Newton's first law. It's also known as the law of inertia. An object in motion will remain in motion. An object at rest will remain at rest unless acted upon by another force. This is why our planets want to stay in motion and until they circle around and get sucked into the sun by gravity. Hopefully not during our lifetime, though. But anyway, so this car is at rest. It's going to require a certain amount of force to move this car. I'm applying force to move that car. However, let's look at the car for a second in terms of net force. Okay? This car is at rest, but there are forces at work on this car right now, and we cannot see those forces at work, but they are at work. What is one force that is at work on this car right now? Out loud, what is it? Gravity. That's right. Gravity is pulling this object as close to the Earth as possible at 9.8 meters per second. Objects accelerate. All objects of whatever mass accelerate to the Earth at exactly the same rate. An elephant and a marble falling from a roof will fall at exactly the same rate, will hit the ground at exactly the same time if they are dropped at exactly the same time. No elephants were actually hurt in the talking of this discussion. So anyway, so all objects fall to the Earth with the same exact acceleration, okay? This car, gravity is working on this car. But there's another force at work also. Forces work in pairs. So there's a force at work downward, right? Gravity. But there's a force working where?
Upward.
Upward, pushing up on the car. With the same force or an unequal force?
Equal.
It has to be. If it wasn't equal, then the force of gravity pushing down, this car would crush the table. Or if the force working in the other direction was greater, it would throw the car up in the air. But it's not. It's sitting on the table. So the upward force, the downward force, has a net force of zero. That's why it's at rest. So net force is kind of like on a paycheck. When you get paid, you get your gross pay. Everything comes in, all the money that comes in. And then before you get your check, they take out taxes. It might be federal tax. They might take out state tax. They might take out money for retirement. And so what you get on your paycheck is called your net pay. So that is what you end up with. So here we have input of forces, of pay, all kinds of pay. But in the end, what's netted is zero because this car is at rest. So now let's look at net force in a different way. Let's change the direction of motion. we always have the up and down force. And as I push this car across the table, if we look, we still have a net force upward and downward of 0, right? That's still a net 0 right there. But I now have a force going in a different direction. So if I'm applying 1 Newton of force to push this car, all right, the car is set in motion. If Micah came up here and he pushed on the car with 1 Newton of force, I'm pushing with 1 Newton. He's here's Micah, because we have to physically distance. So he's pushing. Here, 2 hands, Micah and Dan, Mr. O, pushing on the car. Each of them are pushing with 1 Newton of force. Is that car going to go faster or slower than Mr. O alone?
Faster.
It will go faster. Double the speed, right? Because I'm applying twice as much force. So what is the net force at work? 2 newtons of force. 2 newtons of force to move that car. Mr. O and Micah, 2 newtons of force. All right, I hope this clarifies net force. Does anybody have any questions? You guys are awesome. See ya until next time. Bye.